Right, so we'll start by reviewing the problem, and we will be learning about different things as we uh, go about it. Slightly zoom in my screen so you can see more clearly. So the problem description focuses on forecasting and balancing resources and addressing various project constraints. So in this first problem, we will be focusing on how would you go about managing a project whilst facing different constraints. So the problem descriptions read that you are working as a contractor on a specialist hospital construction project. The contract states that you must finish the work in 40 days from today, or the liquidated damages are £2 million per day you are late. So here, one thing is obvious, that time is of essence, and for any delays, you have to pay huge penalties. So while scheduling a project, it is to be kept in mind. The total project cost is £45 million. Project is being delivered using accelerated construction methods in a relatively short duration. So it's a very expensive and a high risk job. So example can be very sophisticated installations, things like very sophisticated hospitals, or nuclear relations where specialist equipment is required. So your firm has to go in, have to do their job within a stipulated time period, and there is no room for any delays. So the project owner is not willing to make any progress payments. So you can see at one end, the project budget is huge. You are investing quite a lot of money with a total project budget of £45 million, but there are no payments. The payments are released only on work completion. So payment will be only made 40 days from today or at the completion of project, whichever is later. So this is the term which has been agreed for the release of payment. So here we can see, as a contractor, there's a lot of investment upfront. So the owner is not paying too early. Even hypothetically speaking, you finish the job next week and you will not be getting paid. Uh, the situation will be, you could be blocking a lot of cash because it's a very expensive job, and if you deliver it too quickly, you may be okay with the time, but in terms of the uh, cash you have blocked millions of pounds. This could be money borrowed from a banker, so you could be incurring huge amount of interest. So there is no incentive for you to get the job done quickly and block your such a huge amount of cash. So the work should be delivered on time. So the challenge for you is to decide when to commence work on site. So this is a very expensive job, and a job which requires time accuracy. It has to be completed in 40 days, otherwise there are huge penalties. So you are being asked what is the most appropriate period for you to uh, okay. Uh, so Right. In case if there is an issue with the video, you could access the link, and you can just go on the problem set for question 1C, so you do not need to be on the screen. So that may be a way out to address the freezing issues. So the challenge for you is to decide when do you commence work on the site. If you start too early and finish at an early finish time, as a contractor, you stand to lose money in interest invested in the project. right? So you could be paying a huge amount of money to the banker if this is a borrowed money, or you could be blocking a huge amount of the cash, which is always a precious commodity. So, and if you start at a late start time, uh, there is a chance that you could run over time, and as a result, there is a huge penalties which you would like to avoid under every situation. So after a team meeting with senior executives, it is decided to commence work 5 days earlier than absolutely necessary in order to put a little float in the project and to minimize risks, while at the same time ensuring bankers do not eat too much into the corporate profits. So the agreement and the decision made by executive was to uh, schedule a project and to have an allowance of 5 days period and then commence the work. So basically the duration of this project plus 5 days, and then you would commence the work on this project. So all well and good. So the question is, in this constraint problem, how do you suggest we should schedule this project? Where shall we start from? So if you can reflect on this and let me have your thoughts. So will it be worthwhile scheduling this activity as we do normally? Yes, so there is a suggestion that we could start this project by understanding the total duration, which is correct. So let me take this to PowerPoint, which would allow us to edit the schedule and maybe scribble on it. So when we are faced with a project which is constrained, we use and begin the scheduling from the constraint point. So here the key constraint which has been given is that this project must be completed in a 40 days duration. There is no two views about it, and there is no flexibility which is being shown. So we know that the late finish time for this project is 40. So we will use this as a starting point and we'll do a backward pass. So if you could just give it a go and uh, so if you could start by point 40 and start by putting the contractual finish date of 40 in the late finish cell of the last activity and work backwards. So we definitely do not want this project to take any more than 40 days because there are huge penalties involved. So we know and So in this project, rather than starting from the front, as we saw in the normal scheduling activities, we are starting the scheduling from the constraint point, which is the day 40 of the project. So basically, we will calculate the last start of the activity and go in the reverse direction. So the late finish is 40, so that would mean that the late start time for activity A would be 35, and this 35 would become the late finish of activity I, and the late start would be 35 take away 6, which would be 29. This 29 would also become the late finish time for activity N, activity V, and activity M. So we could calculate the late start time for activity N by subtracting 2 from 29, which would give us day 27 as a late start time, and activity V would be 24, and activity M would be 23, and we would be carrying this 27 using this relationship to the activities preceding it. So activity B and activity L will get right. So here I put 27, but we could see that activity L has a connection and a relation with activity N and activity V. So it could have been 24 or 27. And we always know that while doing a backward pass, we should choose the smallest of the two values. So we could have chosen either 27 or 24. The rule of thumb is that in a backward pass, we choose the smallest of the two values. So that's why I have chosen 24 here, which is a merge activity. And activity C would be get late finish of 23 from activity M, which would mean that the late start for activity C would be day 19 of the project, and the late start for activity L would be day 21, and activity B would be day 21 as well, which would mean that late finish of activity J is 21. Now activity Y is a merge activity where we would be getting 21 if we approach it from this arrow, and 19 approaching it from this arrow. So we would be choosing the smallest of the two values, which means 19, and 19 take away 4 is 15. So the late start time for activity Y is 15, whereas activity J, it would be 17. And activity S is also a merge activity where we could have chosen either 17 or 15, and we know the rule of thumb while doing a backward pass is always choose the smallest of the two values, which is 15, which would mean that the late start of the activity S is 14. So this is basically telling us that to deliver this project on day 14, the maximum late start time is 14, day 14. Now in the problem description, the executives have approved a buffer of 5 days. So to calculate the early start time of the first activity, what we would do is we will take this late start time and include a buffer of 5 days, because that's the allowed, and we could basically start this project on day 9, and then we can calculate the forward pass to give us the early start times of this activity, and we could see that if that's the case, 10, and this one early finish activity J would be 14, early start of activity B is 14, and early finish would be 20, which and for let's change the color to differentiate the forward pass from the backward. So early start for activity Y is 10 and add 4 would be 14, and this 14 would become the early start of activity L, and early finish would be 17, and for activity C early start would be 14 and early finish would be 18, and activity M early start would be 18 and early finish would be 24. Activity V early start would be 17, early finish 22, and this is a merge activity, so either we could use 17 or 20, and we know that in a forward pass the rule of thumb is that we always choose the largest of the two values. So that's the reason why we have decided to choose 20 as the uh, value, and this will be 22, and this would mean that the activity I here is a merge activity as well, where you could use either 22 or 22 from here, or 24, and the forward pass we choose largest of the value to allow enough time for all the activities to be completed, and this would mean that the early start for last activity would be day 30. And so if all goes well in a perfect world, we could do an early start uh, on the day 9, and we could have finish it by day 35, and this way we would hit the target. Now we can see the critical path here. So critical path, just remember, is calculated by removing the um, early start from the late start, and I think in this network there is no activity which is which could be defined as a critical. I think this is because of the constraint introduced. Uh, so basically we have to make sure that the activities get delivered on time. So we will be starting on day 9, so we are not starting it too early, so that we do not incur huge financial penalties and interests, and our goal would be to finish it by 35. But if things go wrong, we would have a buffer of 5 days to accommodate things if they do not go as per plan. So this way we learned that in a constraint based situation, we will be starting our scheduling from the reverse side, and we will so in this case the challenge was to deliver this project by day 40, which we used as a starting point of our calculations, and we did the backward pass first, unlike the normal scheduling where we start usually our calculations using a forward pass. Right, so this concludes our first problem. Now we move on to undertake a detailed case study. In this case study, we will be reinforcing the concepts which we have discussed in the earlier problem sets, and we will learn how could we use the critical path method scheduling to forecast and balance resources. So a bit of a theory here first. A key principle in forecasting and balancing of resources is to examine activities with a float and adjust activity start and finish date of a particular activity to coincide with the resource availability. So when we talk about managing resources, forecasting resources, the keyword is the float, because the activities which are critical uh, cannot be moved. They are basically cast in stone, whereas the float provides you with the flexibility to move your resources from one place to another. So to address various constraints, so the constraints the projects face could include things like limited number of workers on your team, or cash flow situations which we will be discussing in this room, which is, or it could be limited amount of equipment. You may delay the start of some activities with float to balance or level out specific resources. So you could make use of the knowledge of the float to balance out the resources. As you manage large complex projects in real life, the principles you will be learning here will remain the same. However, the scale will be larger. So you could have end up with a lot much more big um, number of tasks, but it is very important to ensure that the principles which are used are the same. And these key principles, which we will be revising in this problem as well, include: number one, start by creating a logic diagram, carefully considering physical relationship between various activities. Now, this is very important. And while developing a logic diagram, it needs to be a collaborative activity. It's not just merely a physical relationship between different activities and the precedence order that has to be seen. Very often it is possible that the quality and the safety factors are taken into account. So for instance, you would not like to assign too many contractors to work in a very closed area of the site. So it has to be a collaborative activity, and while doing a network diagram, a wider engagement with the stakeholders is always useful. The second principle is, oops, I think I've moved further up. The second principle, which we will be reviewing, is based on the resources available, determine the duration of various activities and the precedence order. And this should be a collaborative activity, and prioritize the use of resources if the project is facing any resource constraint. So in this problem set, we are going to go through a case study, and in the process we'll be learning about different concepts. So the background of this case study is that you are involved in a highways construction scheme and you have been made in charge of a large excavation project. After meeting with your management team, you have developed a schedule below, which you will soon see. The letter represents areas of the project to be excavated, and here is the schedule. So these numbers here represent different areas of the construction site which have to be excavated. So you could see that the logical sequence which has been agreed by the team. So for instance, activity Y cannot take place until activity K and activity B has been completed, and activity K and B cannot be completed till we have cleared the section W of the site. So you're confident in the durations and the logic. However, this project, which we will be reviewing in this case study, faces two major constraints. Firstly, there are only 10 D8 caterpillars which have been made available for this project. So your company has got just access to 10 caterpillar machinery to do the required earthworks. So you cannot have any more machinery available. So it is important that you make the best use of the resources available. And secondly, the owners are only financing this project up to a £110,000 maximum per month. So you're not going to get any more than that. So ideally, you should schedule your work where you are delivering no more than this amount of work per month. So first of all, certain tasks are required here. Firstly, the case study asks you to produce a Gantt chart for the construction manager, which should indicate the float, or and produce a Gantt chart for subcontractors, and without float information, and produce a Gantt chart for owners using the late start time. So we communicate with different stakeholders using different approaches. So construction managers, they need to be aware of the full picture. So the bar chart we prepare for the management team would include the description of the float. but not everyone, and in particular the subcontractors, need to know this float information. It's possible that if they are aware of that their activities have a float, they could find some other job which they see as a more attractive, and they could sneak out of your site. So we would uh, not be sharing the float information with the subcontractors. And for the sharing our bar chart with the owners, we will be using a late start time. So rather than worrying our owners with the early start time and worrying them if the activities slightly get delayed, we will not be sharing an early start time but a late start time bar chart with the owners. And owners have asked you to provide information on your forecast of monthly progress payments, which we will be. So first of all, we will see how do we go about preparing. So if you have the uh, printouts, you could just uh, go through um, printouts, and we will be uh, going through the different sheets. So the first one which you're being asked is to, so I have moved this to sheet to Adobe, which may allow me to do the edits. So I can use the highlight tool. So we can see in the very first activity. So for the construction manager, we are drawing the bar chart using the early start timings. So we know that activity W is starting on month zero, which is the usual starting point, and completing on the second month. So while drawing a bar chart, we would be indicating that work is being taking place in this zone. uh, then we move to activity K. Now here you can also see how different activities are presented in this bar chart, and there is a certain reasoning for it. So first of all, we take into account the precedence order. So activity W is the activity which is first taking place, and then we take into account the preceding activities. So you can have your own uh, um, methods or how you cluster. Very often we take into account the critical activities and present them on the top. So the first activity is activity W. Then we can move to the second activity, which is just a 1 day, a 1 month activity starting in month 2. So we will draw a bar chart with this, and okay, so I'm trying to see if I could have access to a wider set of tools which would allow me maybe to scribble on this. No, right. So we will be completing based on this, and then the third activity you can see the sequence is activity B, which is starting on week 2 and is continuing until uh, weeks 6. So we could start from 2 to 6. This is how this activity goes on, right? So I have not got to edit tools here, but if you are doing it manually, you could scribble F, F, and F against activity K to indicate that with activity K you have got some float inbuilt in here. or we will just take it to PowerPoint to embed the floats. So at this moment, we are just doing the early start bar chart, and then we can see for activity P, that's exactly the same as activity B. So we would be uh, doing the bar chart for activity B. It should mirror activity B. Then we move on to the activity, which is activity F, which is taking place from week month 3 to 5. So it's starting after month 3 and going on till 5, and then activity O is the next one, which takes place after activity F and goes on for a period of 2 months. And then activity Y, which you can see is starting after month 6, so basically after activity B, and it goes on till 12. So B is finishing here and Y would be starting at this point, and it goes right till 12. And this is followed by activity L, which you can see from here is a 3 months activity. So we would be working on activity here. This is followed by activity U, which is starting after month 12 and going on till 17. So essentially starting parallel to this and going on till 17. And the very last activity is activity S, which is right at the bottom. So this basically gives us the bar chart. So only thing which is missing here is that we have not got the float information embedded here. So for this, if I could just take it to PowerPoint. Oh, that's not a very good screen capture it has given me. So let's try via sniping tool, see if it give us a better view of this. And going back to PowerPoint. Right, so we are basically doing a bar chart for we started by doing this bar chart for the main contractors, but I think what we have ended up is a bar chart for subcontractors. It's a perfect bar chart to share with the subcontractors because it has got no float information. So this is the answer to your part B, where you are being asked to do a bar chart for the subcontractors because it has got all the float information hidden. But for the construction manager, which was the first part of this problem, we can always put the float. So we know that for the first activity, and there was 3 days of float, so we could indicate that even though the work is taking place, we have got some float here. And this information will come in quite handy when we do. And likewise, you could refer to the earlier presented network diagram to see that activity P has got some float embedded. So uh, so we can see in the network diagram that the float for activity P was basically 8 days. So that is a lot of float. So rather than just repeating it, I'm just suggesting 1, 2, 3, 4, 5, 6. So right till activity week 14, this float exists. And for the following activity as well, there is a activity F. There is a huge amount of float which starts from here and it keeps going right till the month F. And activity O also has got a huge amount of float. So you could refer to your network diagram and see that activity O has got a 10 days of float. So basically starting from here and 1 2 3 4 5 6 7 8 9 and 10. Activity Y is a critical activity. It has got no float available. And activity L has got a float of 2. So let's specify it. And this is so we are left with activity U, which is a critical activity with no float, and last activity is a critical. So this is a ideal bar chart to share with the subcontractors. So the third bit asks you to yeah, so this is the chart which should be shared with the construction management yep, team. Yes, so sorry for misspelling. It should be the construction manager. For the subcontractors, you will be presenting an earlier version where you have not got any float link to it. Now comes the question, the third part, where you were asked to do a bar chart for the owners. So for the owners, again, you do not need to tell them the nitty-gritty details of a float of each and every single activity. So the key point being made here while communicating with the owners was that while communicating with the owners, we will not be communicating them the early start and early finish time, because they would get worried, because if things do not start at early start and early finish time, they may be picking a phone and asking you, is why you're not starting on the early start time, without realizing that there was some float built, and that was the reason why. So while communicating with the owners, we will be using the boxes at the bottom essentially. So very similar to the exercise which we did. The only difference will be that you will be using the boxes at the bottom. So for the activity W, it will be just the same. For the activity K, we will be using a late start time of 5 and a late finish time of 6. And for activity F, it will be a late start time of 13 and a late finish for 15. So exactly what we did, but rather than using the top boxes to do your calculations, we will be using the bottom boxes, which basically indicate the late start and the late finish time. So I hope it makes sense. Now move on to the other aspects of this case study. The owners have asked you to provide an information on your forecast of monthly progress payments. So basically, owners would like to know how much they would be incurring, the expenses they would be incurring every month. Right. So I think if you could browse through question 3 part C, and I will see if it's possible for me to open the editable version within Adobe PDF. So just read through it and give me 2 or 3 minutes, so I can see if I could open up um, another version which will allow me to edit. Right. So in this problem, uh, firstly, we have to tell the owners what is our monthly cash flow, and we have to address the constraint which was given to us that this project has got a maximum cost financing of £110,000. So owners are not giving us any more than that. So the problem description reads that the estimating department has provided the following activity table. Activity value is the amount owner owes at completion of each activity, and it includes both the direct and the indirect cost, which includes labor, tools, equipment, materials, site overheads, back office overheads, and profit. So when the total cost is given, basically includes both the direct and the indirect costs. So this is essentially a continuation of the problem which we were discussing previously. So here we have been given a budget of different activities. So for instance, activity W has got a total budget of £45,000. Now, as it is a 2 months activity, the monthly bound will be 22,500. Activity K has a 12,000, and it's just a 1 month activity. That would be what we would be spending on the month when this activity will be undertaken. Activity B has a total budget of 192 grand, and as it's a 4 months activity and we are assuming an equal split in each month, we will be incurring 48,000 pounds for each month. So you can see the total value, the duration of each activity, which is essentially taken from the network diagram presented above, and the monthly breakdown. And this is telling us that the total budget for this job is 1,174,000 pounds approximately. Now, you have been asked firstly to develop a cost-loaded Gantt chart with monthly value of each activity based on the early start and the early finish time. So using the early start and early finish time, the cost loaded Gantt chart. So usually we present only time in our bar chart, which was previously the case. But here we will be loading our bar chart with the cost information, and we will be using it to develop a cost histogram. And once we have done that, we would see what is our monthly requirement. The owners are financing 110 maximum. We will see if that is the situation. Are we incurring any additional expenditure? If so, how do we go about addressing this problem? So let's start by working on this problem. Now, here, as PowerPoint allows us to edit, we could uh, start by maybe looking at our table, and also there are two things which we have to keep in consideration. First is monthly outgoing. So let me bring both of these information. For the time being, I'm not drawing a cost histogram, so I will put it at the bottom section of my screen. And obviously we need the bar chart, sorry, the network diagram to pull the relevant information. Okay, so let's go to the presentation mode and start creating a cost loaded bar chart of our project. So we know the very first activity which is taking place in this project is activity W, which is the very first activity. So this is taking place here, and we are incurring a total spend of 22.5k. So we are spending 22.5 in the first month of our project and 22.5 in the second month of our project. The second activity is activity K, which will be starting after W has been completed, and we are incurring 12 grand budget here. This is followed by activity B, which is essentially critical activity. You can see and activity B is a 4 months activity, and we are incurring 48 grand every year, every month. So for 48 for the 4 months, which is the total duration of this, right? So I have pulled this information from here. The next is activity P, which is also taking place parallel to activity B, and this is incurring 36.1 per month. Right, so we can then move on to activity F, which would start after K has been completed. And if you look at the budget for activity F, it's 48 grants for, so activity F is starting after K, so this will start here, and it would have a budget of 48. And then we would have activity O, which starts after F, and it's a 2 months activity with a 57.5. So after F we have O with the 57.5. Right, so you have got a basic idea about how we are going. Now we could have an idea about the expenses in the initial months. So we can see that in the first month we are incurring 22.5 thousand pounds. In the second month we are incurring 22.5 once again. And if anyone has got a calculator and to give it a go, what's the expenditure in the third month? So let me okay, so it's 96.1. So that's fine, no problem with that. And in the month 4, we can see we are incurring 132.1, and that is the same with the month 5. Okay, and obviously we have not completed the chart yet, but we can see the total expense in the month 5 of this project. It's 141.6. So by the face of it, it's not looking good. We can plot it here and produce a cost histogram. So for the first month, it's 22.5, then 22.5 continuing. Then we move to about 96, which maybe somewhere around here. Oh, it should be straight. And then all of a sudden peaking at 132.1 here, and then moving to 141. So this is beyond. So this should be read as a pound. So they're all working in a pounds currency. Right, so we can see immediately some problems emerging here, and things are not looking uh, as it was desired. Right, so as we have got a limited time, I will jump to a nearly completed solution, and so once you completed it, your uh, cost histogram could look somewhere like this. So once you have completed your bar chart and included all the costs, so here for instance we did complete up to this point, and then you can see the costs for activity Y has been indicated. Activity Y starts after activity K and B, and it goes on. So I'm sure you have got a good understanding of how these costs are developed, and we have ended up with this cost histogram. Now we know that there is a problem area, and it is the area above the blue line. Our owners have agreed maximum finance of 110,000 pounds. So we have to do something about it, which would mean delaying a few activities. So the first question is looking at the first activity with a float is activity K. So do you think using the float for activity K, would it make any difference to help us address this constraint of not exceeding 110,000? So that's good. So owners have a ability to finance the project to a maximum 110,000. First question was, how do we get rid of this peak, which is beyond the constraint point? So we have got a cost overload in the month of fourth, fifth, and sixth month, which needs management, and we are exploring different options. And my first question was, will postponing activity K would make any difference? And the suggestion was that this would not make any difference. It is going to make the situation worse, because all you can do is do activity K in month 4, 5, or 6, which will further increase the cost overload, and it's not going to be a solution. So we dropped this idea. Now there are certain other suggestions which include looking at activity P or looking at activity O. So as we propose different solutions, we need to go back to our network diagram and see the overall impact. So I think moving activity O would could possibly reduce cost overload in month 6, but it would have no impact in reducing the cost overload which exists in month 4 and 5. So this suggestion to postpone activity P seems like a plausible option. So we have got some float available here. The other option that could be explored is postponing activity F by utilizing the float. What are thoughts on this? Now looking at a network diagram, F has a relationship with activity O, so delaying F would have a impact. So F could reduce the cost overload in month 4 and 5, and still we have to do something about the cost overload in the 6th month. So we have decided to move this combination of F and O. So both of these activities are anyhow interconnected. So moving both of them by utilizing their float, we have tried to get to a more leveled resource profile. Now, when we talk about resources, cost may be all right, but when talking about managing our labor, managing our equipment, we do not like too many peaks and troughs. Our intention is to have a very leveled resource profile. So there could be many options. There is no uh, hard and fast rule. So you could have explored different other options, and it's possible that your team decide an option other than F&O, which is absolutely fine. There are certain principles which we adhere to is to ensure that the resource levels are equivalent. We have not got any a lot of peaks and troughs, and the impact on the subsequent activities is reduced. So key reflection points in this exercise was that floats gives us basically the management team the ability to manage different types of resources. From a resource management viewpoint, float is much more important than the critical activities, because with critical activities, there's nothing much you could do. With critical activities, management has no choice. Float gives managers the ability to fine tune the project and better manage cash flow and other resources. So a point made, and we now go back to uh, the problems which we were. Okay, so the question of a point, yes, the that's right. It's not two separate questions, and we have addressed the last point, which is owner has asked you to have a maximum cost guarantee. So this is essentially being addressed in this part. So there's no need to repeat the same thing. Uh, Perfect. So we did this, and we are now moving down. You could take a printout, and you can this thing. The other thing which we wanted students to explore was to draw a project progress S curves. S curves plot cumulative costs and not the monthly costs. And you have been asked to comment on the shape of the S curve. So if the S curves are too steep, it may be a sign the contractor is front loading and overbilling the owners. So very often contractors indulge in a practice where without actually doing the work on site, they front load so that they could get extra payments for different reasons. They may be trying to cover up the retainage which owners are keeping, but this sort of a practice creates a lot of a mistrust. So very often the shape of the S curve is studied to make sure that no one is playing a foul game. Right, so the next thing you were prompted to do was to draw the S curves. So this may be a point for us to uh, do a quick review of some theory. So again, if we could just go to the theory. So these curves are known as a progress S curves or banana curves as well, because the shape of these curves very often resembles that of a banana. So these are very important engineering management tools. Secondly, they provide a visual tool to track progress of a project. So very often when you're managing portfolios of project, it may not be possible for you to go into nitty-gritty details of every single task involved in a project. So having a look at the progress curves give you a better idea. You can have a look at number of different projects taking place and how they are progressing, and it allows project managers to quickly identify project slippages. Right, so going back to the same problem which we were discussing before, we did produce a resource cost loaded histogram where we did see these were the costs. But to draw the progress S curves, we do not need the monthly totals, rather we need the cumulative value. So the cumulative one is that by end of month one, it has incurred a total expense of 22.5 thousand. And as we move to the second month, 22.5 add 22, in total we have spent 45, and we should have spent 45. And by the third month we should have spent 45 add 96.1, which is 141, and then adding 232 to 273. So this one is hiding the view. So your progress S curve, which is based on the early start times, may look somewhat similar to this. So here we will be using those cumulative values. So the first one is on 22.5. As you see, as we move to the third month, our total spend is 141,000, and as we move to the fourth month, it is 273, and as we move to fifth, so using this data, we have plotted it as a curve, and you can see exactly like a S shape, but it slightly resembles the S shape with a very slow beginning towards the end, and then from month 3 to month 8 in particular, you can see the momentum of the project picking. So there's appears to be a lot of work done, and right at the end of the project, so from month 13 to month 19, you can see it's a very slowed down progress. So this is very typical of construction projects. So here we have drawn an early start progress S curve, which is one possibility. The question was, we were discussing the banana curves. So this could be one side of the curve. What is the next side? So any reflections on that? How do we get the other end of the spectrum? So we have drawn an early start progress S curve. What is the other extreme on which we could get another S curve? So yes, so that would be a late start. So the second one which we would be doing is a late start one. So here in the early start S curve, the first month cumulative spend was 22.5. The second month cumulative spend was 45 grand. Third month 141. So using this information we have plotted, we can see from the early start S curve that it's a low slope indicating a slow progress, which is also reflected by not a great deal of money being spent in the early stages of the project. But in the middle of a project, there's a relatively steep slope, which is indicating some rapid progress being made. And as we come towards the end, there's a slow slope indicating a slow finish towards the end. Right. So I did mention about this practice of front-end loading by the contractors, where they bill the owners without actually delivering the work, which creates sometimes the mistrust. So owners can see if there is a very steep curve, which could ring a bell that contractors may be front loading. Right, so the other extreme is to develop a late start S curve. So this is based on the late start bar chart. So here you can see one thing that as it's a late start bar chart, we are using all the float up front, and the work is taking place right at the end of each activity. And using this late start, now it is not recommended, because here if you deliver a project like this, you have got basically no float, and if things go wrong, uh, it's very highly probable that you may not be able to meet the project end date. But for plotting the graphs, it tells you the other extreme, which is possible. So this is the other extreme, which gives you the lower end of the S curve. So here you should note that the work is taking place based on the late start and the late finish times. In the early start S curve, the project work was taking place on the early start and the early finish time. And you can see the difference it makes by the third month. The cumulative spend by the late start way of working is 93,000, whereas in the early start we have spent 140,000. So things are taking place very slowly in a late start S curve. Now, once we put both of these curves together, we get what is referred to as a banana curve. Now, a little bit of a theory about how these curves are used. So a lot of the time, executives use this to manage by exception. So they will be monitoring your actual progress as you report the progress through your project timeline, and will see whether you are falling uh, within this curve. Ideally, you should stay closer to the early dates. But even a middle would be expected. But if you start falling out of this curve, that may trigger management by exception. And for instance, if you're doing a very high spend, and you're or if you're making even lower than the late date, that would trigger a management by exception, and some clarity would be sought. So management by exception involves that usually the senior management would ignore the minor fluctuations in the project, as far as the project is staying within the two layers of the banana. But as soon as you try to overrun one of either the top layer or the bottom layer, that would trigger management by exception response. The second point being made here is it serves as an early warning system, and it's a favorite tool used by many senior executives. In a visual manner, they could track the project. Now, there are different tools. Microsoft Project or SureTrack cannot generate banana curves. They can give you a curve based on the early dates and based on the late start dates. Primavera does help you combine both into a one piece, but I think there are a lot of updates, and so you need to check the software capabilities if you are planning to use management by exception. Right, so that was the theory behind this, and now we move to take this problem to management of equipment. In this problem, we will learn how we can use the same concepts to manage our resources. So the problem given here is that you will learn to create equipment loaded schedules on an excavation project. So using the same case study, the company has only 10 D8 caterpillars, and we have to report how many are needed on this project on a monthly basis. So we are constrained by resources. We cannot have any more than 10 D8 caterpillars which are required for this excavation job. So we have to make sure, as we plan our resources, we do not exceed the constraint of 10 which has been given. The process and balancing equipment is very similar to the process used for the costs, as you learned in the previous example. So key steps would involve analyze the number of equipment needed for each activity, create a bar chart indicating the float, load the bars with equipment to be analyzed, and examine loading and adjust the bars within the float as desired. So here you can see different activities and the duration and the number of the caterpillars which are required for each. So as we are not dealing with costs here, we remove or we do not consider the data in the right two columns. All we are interested in is the number of the machinery, which now let's go through uh, the presentation and read through some theory and how we will be uh, tackling this problem. So balancing equipment usage. Firstly, schedule loaded with equipment is often referred to as equipment loaded schedule. In comparison, we were talking about cost loaded schedule in our previous example. Forecasting equipment is very similar to forecasting cash. So we create a bar chart indicating floats, and we load our bar charts with the equipment information, and then we examine the loading and adjust the bars within the float to ensure that we are addressing the required constraint. So here is a worked out example. So very similar to the cost loaded bar chart, we have created this bar is hiding the view, so I will skip the presentation mode and go in here. So we have used this network diagram to plot our histogram. So as before we saw, the first activity was W requiring two caterpillars. So we have been given the resource requirements, and this time we have loaded our resource requirements onto our bar chart. And then activity K required 1 caterpillar, activity B required 4 caterpillars, and activity P required 3 caterpillars, and so on and so forth. And using the information in the network diagram, we have completed the equipment loaded bar chart. And then we have this information to plot the number of caterpillars required, and we have got no issue at all in the earlier months, but as we get into the fourth month of the project, we are starting to exceed the given resource limit. That is one issue. The other issue is that you can see this resource histogram have got quite a few peaks and troughs. We do not like waste, so you may have a site where on the third month you have got 7 caterpillars, and then on month 11 we would like to have a more leveled resource file, so our machinery is not sitting around. It's not easy to mobilize a heavy equipment machinery. You have to pay charges to get them on the site and then get them off the site, and once on the site we would not like the heavy machinery sitting lying there and wasting our resources and also increasing our risk in our way. So our intention is to have a more leveled resource profile. So any thoughts on how do we go about it? I think one option was using the float on activity K, but you can see that this is float which lies within already a resource overloaded area, so that doesn't look like a plausible option to utilize. So you are left with utilizing a float for activity P, F, or O to get rid of the resource overusage. So here you can see the decision made by the project manager uh, and the decision was made to postpone activity F and O, very similar to the way the cost loaded decision, because if you delay the activity F, it would have a knock-on impact on activity O. It would help reduce the resource overloads, delaying these two activities. So the decision was made to postpone by activity F and O by 3 months, which will take and remove this resource overload and will give you slightly more leveled resource profile. Okay, so I think that basically summarizes uh, the key concepts and right. So that I think was all that we wanted to cover in our session today, and we learned how do we go about managing our costs. We learned how do we use the banana curves to manage by exception, how do we go about drawing it, and how do we uh, manage the constraints, whether it is a cost constraint or a time constraint. All right, so that is, I think, all which I wanted to cover today in terms of the problem sets. Now we have got some additional time which can spend if there are any questions, any queries, concerns with regards to the coursework uh, and just to catch up with how things are getting along. So just make sure that you're just doing these as I said, we are not expecting that students will be spending loads and loads of their time just producing a very neat version of these problem sets. All that is required is an evidence.